Welcome you all. Today we are going to discuss about RSA algorithm. This RSA algorithm is an example of asymmetric key encryption, which was developed by Ron Rivest and Adi Shamir and Len Adleman at MIT in 1977. As I said, it is a public key cryptographic algorithm, or in other words, we can also say it as symmetric key encryption algorithm. This RSA algorithm is a block cipher algorithm in which the plain text and ciphertext are integers between 0 and n minus 1 for some n value, and the typical size of n value will be 1024 bits, or it will be 309 decimal bits. Okay, so this RSA algorithm follows integer factorization problem. The security of RSA algorithm is basically is based on the difficulty of this integer factorization problem. So it is a one door trapdoor function where we will be computing the product of two prime numbers. So we will see these steps in upcoming slides in an algorithm format also. So first we will be computing the products of two prime numbers, which was easier, and we will be computing the decryption standard, like the value of E, N, P and Q are much easier. So the computing of D is very much difficult. So this makes this algorithm success. Okay. So how to calculate this algorithm? The algorithm description is given in this particular site. C is nothing but your ciphertext and M is nothing but your plain text. So C is calculated with the help of formula M to the power E mod N. What is M is plain text and E is an integer value which we have chosen, which will be relatively prime to phi of N. Okay, and then what is M is given by formula capital C to the power D mod N. What is C is the calculated ciphertext and D is the calculated key value with the help of the chosen integer value. Using that we can find out D value. Using that we can decrypt the ciphertext which has been sent. Both the sender and receiver must know the value of N, and the sender knows the value of E, and only the receiver knows the value of D. This D will be computed with the help of the E value. Okay, hence the public key will be given as PU as E comma N, and private key will be given as D comma N. As I said, this is the algorithm that has been given in an theoretical format here. So for this algorithm to be satisfactory, the following requirements has to be met. What are these requirements? Number one, it is possible to find the values of E, D and N such that the M to the power ED mod N is equal to M. So that is E is the chosen integer and D is the calculated value with the help of E, and N is the given number, which I said it should be 1024 bits. Okay, using that we can calculate the ciphertext. And the second requirement is it is relatively easy to calculate M to the power E mod N and also C to the power D mod N. What is M to the power E mod N is nothing but the ciphertext. C to the power D mod N is the calculation of your plain text. This is also relatively found to be easy. But what is infeasible over here is with an information of E. Okay, it is highly impossible to find out the value of D even though we know the value of E and N. This is the speciality of this RSA algorithm. And in RSA algorithm, we also calculate the Euler Torsion function of the given N value. So we already know N is calculated with the help of formula P into Q, that is multiplication of two prime numbers. Since it is given as N is equal to P into Q, in the place of N I have substituted P and Q. So P, we know that it is a prime number and Q is also prime number. So I have rewritten this as phi of P into phi of Q. So according to Euler Torsion function, if the P value is the Euler Torsion function of the given N value is a prime, then the formula is P minus 1. Okay, so since P is prime, it is P minus 1 has been substituted over here, and Q is prime. So Q, instead of phi of Q, Q minus 1 has been substituted over here. So this is the function calculation of your Euler Torsion function calculation of your N. Then we have calculation of the D value, that is private key value. So which is given by formula ED is congruent to 1 mod phi of n. From this I can calculate D, because E is the chosen integer, which is given as E inverse 1 by E can be written as E inverse mod phi of n. So using this formula, your receiver will calculate the value of D, and that key will be used for decryption, where E will be used for encryption. So we will see that in an algorithm format. Here the algorithm has been depicted in a step-by-step manner. First I need to choose two integers, one is P and Q, and both the integers should be prime and it should not be equal to each other. That is my first step. Then I have to calculate the value of n. We already know the value of n should be 1024 bits, which is the multiplication of two prime numbers. Okay. Then I have to calculate Euler Torsion function of n, which is as we discussed in earlier slides, it is p and q are prime number. We have substituted as p minus 1 into q minus 1. Then I have to select an integer e such that the integer should be relatively prime to phi of n. That is why the condition has been given over here, GCD of phi of n comma e equal to 1, and that e value should be between 1 and phi of n. And using this e, encryption will be done, and in the decryption part I will be using the d value, which is calculated with the help of the formula d is equal to or congruent to, this is an congruency symbol, congruent to e inverse mod phi of n. Using this I can calculate the d value. Since my D and E value has been given, the public key pair is given as E comma N, and the private key value is given as D comma N, where public key will be used for encryption and private key will be used for decryption. As I said, this is an asymmetric key encryption. So as I said, E is the key used for encryption. So C is equal to M to the power E mod N, and plain text M equal to C to the power D mod N. So this is the overall RSA algorithm. We will see an example about this working of this RSA algorithm. Here I have been given an example: P equal to 3, Q equal to 11 and E equal to 7, M equal to 5. First I have to check whether the given value P and Q are integer, where P equal to 3 and Q equal to 11 both are integer, and I have to check whether it is a prime or not. I know that 3 and 11 are prime and both are not equal to each other. So according to my algorithm, first step is getting satisfied. Second step is I have to calculate the n value, that is multiplication of two prime numbers. So P into Q is equal to 3 into 11 equal to 33. So now I have the E value, so I can go for encryption. So encryption has been done over here, which is given by formula M to the power E mod N. So what is M value? 5 has been given, E value 7 has been given, mod 33. So this can be founded with the help of like this. So 5 to the power 676, which is given as 16 mod 33. So 5 to the power 6 is 16. So mod 16, 5 to the power 6 mod 33 is 16. So remaining is 5 to the power 6 into 5. So 16 has been substituted in the place of 5 to the power 6 into 5. 16 5s are 80. Again 80 mod 33 is given as 14. Now it has been sent in my communication channel. In the decryption side, I have to calculate my key D value. Using that only I can decrypt it. So it is given by formula M equal to C to the power D mod N. To calculate D, I need the phi of n, that is Euler Torsion function. So that has been calculated over here. So phi of n equal to phi of P into Q, where P and Q are prime number. So instead of phi of P, I have substituted P minus 1. Instead of phi of Q, I have substituted Q minus 1. So what is my P value? It is 3. 3 minus 1 is 2. And what is my Q value? It is 11. 11 minus 1 is 10. So phi of n equal to 20. Now I have a formula to calculate my D value. D is equal to E inverse mod phi of n. What is my E value? It is given as 7. 7 inverse mod phi of n. I have to find out what number if I multiply with this 7 and take modular operation, and that will give me one value. 7 ones are 7 mod 20. I will be getting remainder as 20. 7 twos are 14. 14 mod 20 is again 14. It is not equal to 1. So 7 threes are 21. So 21 mod 20 is equal to 1. So 3 is my D value. So using that I can decrypt it. So M is equal to, I already know the ciphertext value is 14. 14 to the power 3 mod 33. I know 14 square is 196. 196 mod 33 is given as 31. So I can substitute it in the place of 14 power cube as 31 into 14 is equal to 434. If I take 434 mod 33, I will be getting 5. So whatever I have sent, I have received. See that here the question given in m value, the value given in question is equal to 5, and I have retrieved back the 5 value using the different key. Though I use different keys, whatever I have sent, that has been retrieved back in my receiver's end. So that's all about the working principle of RSA algorithm. So if you know the algorithm and the conditions are true, you can easily find out, you can easily work on and find out the D value, and you can encrypt it and decrypt it. Keep it in mind the P and Q should be a prime number and it should not be equal to each other. Then when I am choosing an integer E, that E should be relatively prime to phi of n. Here the E value is 7, so and phi of n value is 20. If I take GCD of 20 comma 7, it will be equal to 1. Hence the condition is satisfied. That's why my D value, whatever I have calculated, is able to retrieve back my original message content. If I am not choosing properly the E value, which is not relatively prime to phi of n, then I will not be able to retrieve this plain text that has been sent by the sender. So that's all about my RSA algorithm. So these are the another example which has been given. So which we can take it as an homework. So what is the security of an RSA algorithm? So it is when we talk about this security of an RSA algorithm, it is highly secure. So brute force attack is possible. So what do you mean by brute force attack? This involves trying all the possible private keys, and it requires number of trials, quite number of trials. Okay. Then the second type of attack is mathematical attack. There are several approaches for this. All is equivalent is effort to factoring the products of two prime numbers. And then timing attacks, these timing attacks depend on the running time of decryption algorithm. Countermeasures can be taken to prevent the timing attacks are constant exponentiation, like blinding and random delay can be done. And the final attack is chosen ciphertext attack. So this type of attacks exploits the properties of RSA algorithm. So this is all about your RSA algorithm. So if you know the algorithm, it is very easy to calculate the ciphertext and plain text. It is an excellent example for asymmetric key encryption or public key encryption. Thank you.